Welcome back. Hope you guys are staying healthy and safe. Going through this lesson today, we're going to be talking about intro into 3D figures, which seems like a really simple thing. It's three-dimensional figures are super easy, but there are some pieces of vocab that we need to know because they're not very traditional on the things that we talk about with some of these things. For instance, the vocab here we have face, base, vertex or vertice, and edge. Those are not common things that people typically talk about when they're talking about a three-dimensional shape. It's like, wow, that Rubik's Cube has so many faces or so many bases. It's not exactly a conversation starter, but we do need to know the vocab words. And so from this one, it says they're the faces of the three-dimensional figure. It's any three-dimensional figure. It has surfaces, including the bases. So the faces are all of the sides of a three-dimensional figure. But specifically, when we look at a three-dimensional figure, there are faces and there are bases. They can't be both, but we have to go ahead and decide that, which we'll get to in a little bit. But the first one here, the base of the three-dimensional figure, it says there specifically, it names the shape. So if the shape's a triangle, then that means it's going to be a triangular prism. If it's a rectangle, it's going to be a rectangular prism. If it's a pentagon, it'll be a pentagonal prism. It's naming the shape because that's the shape of the base. And then it says there the prism has two bases which are parallel to each other and do not touch. Alright, vertex. You'll see me write this one as vertices. That's the plural of vertex. There's more than one. So vertex and vertices, they're the same thing. But a vertex, it's a corner of a three-dimensional figure. So it's just the corner pieces of all of the sides there. And then an edge, the edge is the line segment that joins two faces. That seems really complex, but if you look at, say, a box, it's the edge of the box. So the edges around the box, that's what we call the edge. It says specifically line segments because you're joining two of them together, but that's a very mathy way to say just the edges. Okay, so some different things that you could see three-dimensional figures. You could think of a lot of different ones. Maybe in the comments below on this assignment in Schoology, go ahead and maybe comment a couple of ideas that you have for what three-dimensional figures could be that you would see every day. Three that came to my mind, the very first one is cereal boxes. They're three-dimensional figures. They're usually rectangular prisms, but sometimes you could have a different type shape of box. Another thing that was very common that I saw was books. A lot of books are rectangular prisms. And last but not least, canned soup. Canned soup is a three-dimensional figure. It's a cylinder, and that cylinder is a three-dimensional figure. But anyhow, you could think of a lot of different ones, and if you have any that come to mind, it's basically any objects that's three-dimensional, but we don't want to have irregular shaped objects, like, for instance, like an Xbox controller. That is a 3D figure, but it's not one that you can name, whereas a cereal box, it's a rectangular prism. It's only one shape. It's not a composite of many shapes. Okay. And then, so for this next part, each three-dimensional figure has specific properties, and what that means is it has specific things about it that will describe it. Okay, so of that one, labeling the vertices, edges, faces, and bases of the figure below, I would go ahead and see first off that every face, for this one, it's either a face or a base. So we would decide what it is. If this right here is a face, then that means this one right here is a face. That one right there could be a face. There's lots of different ways to look at it. But there's also an edge, and you'll notice that this edge, it went from one side over to the other. That's connecting two faces here. So that's why it had a little math definition there, like in our definition. It's just the edge or the pieces on the outside. And then last but not least, that would be a vertice. The single would be vertex, but since there are multiple of them, we call it a vertice. Same thing on the rectangular prism. I would go ahead and label this one right here as a base, And then this one right there is an edge, and that one right there is a vertice. So we would have all of those ones. We could label all the rest, but I'm just going to label 3. Now looking at a cube versus a rectangular prism, how are they the same? And then what makes them unique? So first off, they are the same because both of them have 8 vertices and 12 edges and 6 faces. So if I look at this one, there's 1, 2, 3, 4, 5, 6, 7, 8 vertices, those little corner points. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 vertices, so they both have 8 vertices. The 12 edges, I would just count all the edges around, which is going to be 12 each. And then the faces, they're including those bases. We have six-sided dice, and this would be like an eraser or something, or a cereal box that has 6 edges. They're the same. But what makes them unique? There's lots of different things that make them unique, but specifically, the cube has 6 faces that are all the same. The rectangular prism, it has faces that are not the same. Like there are some that are similar, or some that are the same, but not all of them are the same. And that would be a major difference between a cube and a rectangular prism. Alright, next type. So we're going to go ahead and complete this table of information here, and we're going to go ahead and, based off of its properties, we're going to go ahead and use colors to shade this in and get the various parts of this. And hopefully if you guys on a scratch paper, maybe you want to draw these shapes or attempt to draw them and shade them in with me. But very first we have a cube, so I'm going to go ahead and name it. And then the number of faces, we already said a cube has 6 faces. And then what shape are those faces? Well, they're squares. In order for it to be a cube, it has to have all squares. Then I go ahead and say, it says here, color the faces blue. So I'm going to go ahead and shade the 4 faces blue. Notice I didn't shade the top or the bottom. That is going to be actually our base, and there are 2 bases. They are both square. And I'm going to go ahead and shade that in red. And then the vertices, I'm going to go ahead and just start counting them. Again, I count all of the corners here. That would be 4 there and 4 here for 8 total vertices. And I'm going to go ahead and label those green. So you'll notice every corner was marked with green. And then the edges, I'm going to go ahead and do line segments here. And we already said earlier that there were 12 of them. So I could go through and do each one. Let's see, I put a line segment, line segment, line segment, line segment. And I just keep going, and I connect all of them. So I would go ahead and put all my line segments together, and you would see, again, we have our 3-dimensional figure, and we have our bases and faces labeled. Okay, the next one, what is this one called? It should be a rectangular prism. And since it's a rectangular prism, we know that there are 4 faces like the square, but they are 4 rectangular faces. So I'm going to go ahead and color that in. And you'll notice I skipped a little bit on the top and bottom here, and I'll keep going through that. But there are 2 bases, and they are both rectangles. And I'm going to go ahead and shade those. And then I go ahead and mark my vertices. So in this case, there are 8 vertices. It's like a squashed cube, so that would be the same number of vertices and also the same number of edges. So I go ahead and draw those in, and now we have a rectangular prism with the faces and bases labeled or colored in. If this is a rectangular prism and the bottom here is a rectangle, does that mean this one down here is a rectangular prism because this bottom piece is a rectangle? Well, if we go back to the definition, it has to be parallel to the other side, which this rectangle down here is not parallel to any other rectangle in the shape, so this can't be a rectangular prism. But if you notice that this triangle here and that triangle there, they're parallel to one another, and since they're parallel to one another, that names the shape. That makes this a triangular prism. So because it's a triangular prism, I go ahead and count the number of faces, which there are 3 sides of a triangle, and that means there's 3 rectangles here that I'm dealing with, and they're all rectangular of the faces. I'm going to go ahead and draw those in, but this one's kind of tricky, so I'm going to just draw it all in, and then you'll see me shade in a little bit differently. The next one is the bases. They're triangles. We've already identified that. So I'm going to say there's two bases because there's two triangles, and they are triangle shape. Then I'm going to go ahead and color those in. And then with the vertices, I go ahead and count. We have 1, 2, 3, 4, 5, 6. And I'm going to go ahead and mark those. And then with the edges, there's 3 here, 3 there, and then in between the two triangles there's another 3. So that means there are 9 total edges. And so I go ahead and put them all together, and there we have a triangular prism. Okay, next type. We have on this one a pyramid shape, and we have to label what kind of pyramid it is, but it's a rectangular pyramid. And the reason for that is this bottom piece, it's a rectangle. It could be a square, then we'd call it a square base pyramid, but we don't know if that's a square because there's not enough information, so we call it a rectangular pyramid. Since it's a rectangular pyramid, I look at the faces here, and there are 4 faces because there's 4 sides on a rectangle, and those 4 faces are triangles. So I'm going to say 4 and triangles, and I'm going to go ahead and color those in. The base here, there's only one base, and that base is a rectangle. So I'm going to color that one in. Then with the vertices, there are 4 vertices on the bottom, and there's 1 here on the top. So that means we have 5 total vertices. And then the number of edges, we have 1, 2, 3, 4, 5, 6, 7, 8. So we would have 8 edges to color in. And there we have a rectangular pyramid. If this one is a rectangular pyramid, what would this one be? Notice this bottom piece, what shape is that? It's a triangle. So this would be a triangular pyramid. So fancy, I know, math's so creative. Since that's a triangular pyramid, I go ahead and label the number of sides, which in this case there are 3 sides of a triangle, so that means there's 3 faces, and those 3 faces are all triangular. And I'm going to go ahead and color those in. And then we have the base, which is a triangle, and there's only one of them. So we'd have 1 triangle for the base. And then I go ahead and count the number of vertices here, which there's 3, 4 total vertices. And then I count the number of edges, but in this case there are only 6 edges. So I would have all 6 of those labeled, and now we have our triangular pyramid done. What do you notice the difference between the pyramids and the prisms? A very stark difference that you should notice is that prisms, they have rectangular faces, and they always have 2 bases. Whereas pyramids, they have triangular faces and only 1 base. And then last but not least, what makes a triangular prism unique? So if I were to go back to this shape here, what makes a triangular prism unique? Well, the reason why that one is going to be unique is that it has 2 triangular bases that do not intersect. Okay, hopefully this was helpful for you. Good luck on your assignment. Please let me know if you have any questions or concerns. Reach out to me either on email or even comment in this question here, on this assignment. And then if you have any questions or concerns about submitting this on Schoology, please refer to the videos that I sent you to be able to submit this. You don't have to take a printout of this assignment that's coming up. You just can take a screenshot or a picture of it, or you can even write it on scratch paper to submit it. But please do submit that on Schoology. Thanks for all your help, and have a great day.